Miss Levy. That looks like more of an office. I'm gonna tell your supervisor that you need to meet from that. You know, those other two places that look pretty shaky. I don't know, like a dungeon. All right. Let me throw a couple of problems. Oh, I'll show you this. I just thought you might want to write this down. This is just some kind of indicator, not 100%, not concrete, but just something to kind of guide you on when you need to use which method. So I'm going to leave that on the board there for a few minutes and let you write that down. I'm not going to go through and explain it because it's pretty self-explanatory. But that shows you when to use. And I added this morning, and I'll show you this in just a second. I'm going to let y'all write that down. Okay. Now, another good way to tell if you're using the shell method is if you have a function, and usually most of your functions with the shell are going to look about the same. They're going to look something like that. If you look and you're rotating around this axis and you're using the shell method, then this is going to be your outside diameter, and this is going to be your inside diameter. But it's the same function. Usually, when you have the outside and inside diameter, and it's on the same function, that is pretty much a guaranteed shell problem. Okay? If the outside diameter and the inside diameter are on the same function, usually it's the opposite. Usually the outside diameter and the inside diameter are on different functions. And if they're on different functions, then it's a washer. But if you have the inside and outside diameter on the same function, that is usually an indicator you're going to use a shell. And you don't have an inside and outside diameter on a disc because it's solid. Okay, so that's another indicator, the outside and inside diameter. If the outside and inside diameter, there is none, then you got a disc. If the outside and inside diameter are on two different functions, then you got a washer. If the outside and the inside diameter are on the same function, then you've got a shell. Now, it's not 100%, but that's kind of a guide to give you a little bit of, with this sheet that I sent you this morning, that none of you probably printed out, but it helps you with this sheet right here. Okay. Now, let's go ahead and do a couple of problems, because the best way to learn these is with examples. So with that being said, let's do I don't know if we started this one. I don't know what we did, so tell me if we did this one. Y is equal to x cubed. Y is equal to 0. X is equal to 1. And we revolve it around. Y is equal to 1. I don't think we did this one because I just made this one up, I think, today.
Yeah, we did one that was similar, but it revolved around the.
Okay, yeah, this one's a little bit different. I know this is different because we're revolving around y is equal to 1. And that's, you're not used to doing that. So, with that being said, go ahead and graph it. Draw a sketch and graph it because that's the most important part. So we got a function. Well, all of you know what x cubed looks like. It looks like this. So we're going to draw it. I'm going to draw it like that. Okay. And y is equal to 0. Let's someone do that. Y is equal to 0. That is the x-axis. And x is equal to 1. That is like that. And y is equal to 1 is right here. Y is equal to 1. And we're revolving around y is equal to 1, so it's kind of like the x-axis. So it's this area right here that we'll want the volume of. No, that's green. All right, go ahead and start setting it up. Okay, so since we are going around the x-axis, that means that we have to have everything in terms of y, because we are dealing with a shell and it's going around the x-axis. So let's turn back to our cheat sheet. Shell revolving around the x-axis, you have to have everything in terms of what? What does it say right here?
In terms of x.
Everything in terms of what?
In terms of y.
In terms of y. It says it right there. So your finished product will look like this. So with that being said, and I think I told y'all that yesterday, I said when it's a washer, it's different. But when it's a shell, you have to, if it's around the x-axis, and this is the x-axis, because it says it right there, revolve around, y is equal to 1, well, this is the horizontal axis right here. So that means that we're going to have to put everything in terms of y, which means we got to solve for x right here. So I'm going to take my my red marker, and I'm going to solve this for, and that's y to the 1/3 is equal to x. So that's technically my, we're going to revolve around, so that means that I'm going to draw that right there, and it's going to revolve around the y-axis. So it's going to start down here. So I guess it's going to look like it's going to be like this. I'm thinking out loud, like that, and then like this. It's going to have a funky look. It's going to look like a hollowed out cube. That's what it's going to look like. So, but it says x greater than 1, or x is equal to 1, y is equal to 0. So it doesn't, so it can go around. So it's going to look like, a cube. And that cube is going to have a hollowed out center. I don't know if y'all can see it or not, because if you go on the other side and you do the same thing, now you see it? Yes or no? Hopefully you can see it. It's going to be a hollowed out center, and I can't draw it, so I'm trying to draw it, but it sucks. All right, so anyway, that's what it's going to look like. And we're going to bear, that's going to be your height, your radius. Let's see, if this is your height, and this, the one right here and one right here. Now you got to be careful here, because you've got to say, what is this spot right here? That's going to be 1 minus y, because this is y, and y is going to be going up like that. So 1 minus y is going to be your height. So that's going to be v is equal to 2 pi from 0 to 1, of 1 minus y, and then this right here is going to be 1 minus x y to the 1/3. 1 minus y to the 1/3 dy. Okay, you got to remember, this right here is your disk, and it's going round and round this y-axis. And it's got to go from 0 to 1, so it's going round and round and round and round and round and round and round. And this circle right here is getting bigger each time as this black cursor moves up. So 1 minus y, because that's being measured as y. So as this moves up, 1 minus, okay, let me show you. 1 minus 0.25, 1 minus 0.5, 1 minus 0.75, 1 minus 0.8, 1 minus 0.9, and 1 minus 1, you're at this point right there. So if you want to set your picture up where you can see it a little bit better, there it is. And the height and the weight, it doesn't matter, the radius, because this is multiplication. So it really doesn't matter which one you do first. 2 times 3 is the same as 3 times 2. So you can put 1 minus y cubed, or y to the 1/3 in front. You can put 1 minus y. Now we got to do the orange. Okay, so we got this. But what about from here to here? Well, you got 1 right here minus, and then you got the actual function because that's the height. Okay, so 1 minus that function right there, 1 minus that function, 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 1 minus that function. So this is your height. And now you just do the calculus. This is the setup. So now you just do it. So that's going to be V is equal to 2 pi from 0 to 1. And I got 1, do your FOIL, minus y to the 1/3, minus y plus y to the 4/3 dy. Okay, now I want you to take the next 2 minutes and I want you to find the volume. So I'm going to put it on. Hold on a second. Hold on. I can't find my clock. There we go. Moved away from me. There you go. I want you to go ahead and do your antiderivatives, plug and chug, and give it to me in terms of pi. Now, Miss Parker, you've been in the dark. Now you're really in the dark. Or you just don't have your video turned on. Which one is it? Yep. She gone back to sleep or in another room probably. That's why people do the ceilings and the don't turn. There she is. Boy, she is in the dark. Couldn't even see you, Miss Parker. Boy, y'all like to stay in the dark, don't you?
Sorry, I like the dark.
That's all right. We could barely see. I mean, I could not even see you until you moved. Y'all should not like to be in the dark. Let's see. Have y'all ever seen that horror movie In the Dark, where these shadows they're in the dark until you shine a light on them? You ever seen that movie? Now that's a scary movie. When you see silhouettes, oh my gosh, that's scary. Oh yeah, it's not a cartoon or a Marvel. I keep forgetting. I'm sorry. Loki was a letdown. The last episode of Loki, that was a letdown. I could have done fine with not even watching it. Anybody else feel the same way?
They kept making all the episodes shorter and shorter too.
Yeah, I mean,
it started with like 45 minutes, and the last one's like 22.
Yeah. And a Loki kissing a Loki, that's kind of like the last movie with Star Wars. The stepsister kissing the step brother or whatever. Just kind of creepy. You know, who was the Darth Vader's grandson? What's his name?
Luke Skywalker was the brother
kissing his cousin.
Leia.
You know, and the girl being the cousin. I mean, that's kind of weird.
No, they were brother and sister.
Yeah, brother and sister. That's kind of strange. All right, so here we go. But I guess in Hollywood, that's normal now. So I guess since you can marry your dog and marry your house, I guess that's just a hop, skip, and a jump for marrying your daughter or marrying your sister. So I guess it's just a matter of time. All right, so V is equal to 2 pi, 0 to 1, and I'm just going to go ahead. I can't combine anything. I'm just going to rewrite it and start on the next page. Y to the 1/3 minus y plus y to the 4/3 dy. I thought maybe we could simplify something, but we can't. So here we go. V is equal to 2 pi, brackets, 1 turns into y, minus y to the, well, if you add 3/3, that's going to be 4/3 over 4/3. And then that's going to be y squared over 2. And that's going to be y to the 7/3 over 7/3. And I'm going to clean this up in just a minute. Evaluated at 0 and 1. So V is equal to 2 pi y minus 3/4 y to the 4/3 minus 1/2 y squared or y squared over 2 plus 3/7 y to the 7/3. Luckily, 0 will take 0 out. So that's going to be V is equal to 2 pi 1 minus, well, 1, that's going to be 3/4 minus 1/2 plus 3/7. Well, we got to get a common denominator. It looks like the common denominator is 28. I don't know. Y'all check me. Let's see. 2, 4, 7, 2, 1, 2, 7, 2, 1, 1, 7, 7, 1, 1, 1. Yep, 28. So V is equal to 2 pi 28 over 28 minus 28. 4 will go into 28. 7 times 3 is 21. 14. 12. V is equal to 2 pi. 28 minus 21 is 7. 7 minus 14 is negative 7. 7 plus 12, I have no idea. 5. Somebody check me on that, please.
Yes, sir.
That's going to be 14. I got 5 pi over 14. What'd y'all get?
That's what I got.
Good job. Y'all are winners. Let me leave this on the screen for a few minutes for the one person that's going to watch the video. And that's a good test question, so make sure you put a note beside that one. That's a good test question. Makes you work a
quick
little
question
bit.
for you.
I'm sorry, what?
I have a question.
Uh-huh.
So for the second and third row, how'd you go from 3/4 y to the 4/3 to like 3/4 and so on?
Plug in what?
Oh, okay. Plug in.
Got to plug in 1. So
Okay,
that
thank
1 goes in here. So that's 1, and then 1, and then 1, and then 1. 1 to the 500 over 3 is 1.
Okay.
So
Yes, sir.
all of those turns into 1s. 1 to the 4/3 is 1. Y squared, 1. 1 to the 7/3 is 1. So it just come down 1 times that is that. 1/2. 1 times 3/4 is 3/4, and 1.
Okay.
Now again, you bring up another point, Mr. Michelle. What have you noticed about the way that I've done all these problems? No matter if it's a shell, no matter if it's a disc, no matter if it's a washer. What have you noticed the way that I do these problems?
They are all step by step.
I do them all as the same step, the same methodology. What do I do first?
You graph them.
I graph them. And then I set up my antiderivative, and then I do everything I need to do. And that's the way you're supposed to do it. Now, you find your own method, of course, but that method usually works good with not only calculus, but with physics, statics, and dynamics, and thermodynamics. I guarantee you there's somebody in here that took calculus before, and they're going, oh my God, I can't believe I'm doing this. I mean, I'm actually doing this. Yeah, it's not that big a deal. All right, so here we go. We may have done this. I don't remember what we got to, but just tell me if we've done it. If not, we've done it. We'll go to the next problem. Revolving around the y-axis. So that means you don't have to solve for x. Everything's in this form. So that means we're revolving this guy let's see. Square root of x looks like this. So y is equal to 0. Looks like this. Y is equal to 0. That's the x-axis. And x is equal to 4. So that means it's going around the y-axis. That means that your dojigger here is parallel with this axis. So that means you're doing a shell. And it's going round and round and round and causing all these cylinders. These cylinders are going to look like this, and of course, it's going to be looking like this all the way around. Which looks kind of like that, like y'all said before, that I can't draw it, but that the cone where y'all said that you pour put a penny in, it goes round and round, it's kind of raised up. A little bit raised up. I know, I suck. I don't want to hear it. Unless you can draw better than me. There we go. It looks something like that. Kind of. More shallow. But we're going from 0 to 4. So V is equal to 2 pi from 0 to 4 of x, because x is equal, this is x right here, that's your radius. And your height is equal to your function. So that's going to be x times x to the 1/2 dx. All right, I'm going to let y'all work it. Go ahead and work it. I'll let y'all work it for a couple of minutes. And see how we come out on the other side. Any mail? Sorry. Thought I hit the microphone. I was hollering at my son, which he can't hear me because he's on the other end of the house. That's how people on farm communicate. We just yell. Yeah, he didn't hear me. I have to text my son because he can't hear.
He probably has headphones in.
What?
I was saying
What'd you
he
say?
probably has
Yeah, he probably got them dang headphones on. Okay, so we've got V is equal to 2 pi. And this is x to the 2/2. So that's going to be 0 to 4 of x to the 3 halves.
Hubert, you
dx.
stopped sharing your screen.
Say again, what?
You stopped sharing your screen for some
Oh,
reason.
I hit the wrong button a while ago when I meant to hit the microphone. I'm sorry. Thank you for communicating. See, that's what happens when you communicate. For some of you people that don't understand communication, that's what happens. It's called the squeaky door gets the grease. The person that don't communicate gets the worst office on the floor. All right, v is equal to 2 pi of x to the 5 halves over 5 halves, evaluated at 0 and 4, all multiplied by 2 pi. And that's v is equal to 2 pi. I'm going to clean this up. That's going to be 2/5 x to the 5 halves, evaluated at 0 and 4. And you don't have to worry about the 0 because it pretty much cancels itself out. So v is equal to 2 pi times 2/5 4 to the 5 halves. Well, what's the square root of 4?
2.
2 to the 5th power is 32. 32 times 2 is
64.
64 times 2 is
128.
128 pi.
Did you say 4 or 2?
Okay. Say again.
Did you say 64 times 2?
Should be 128.
Yeah. I didn't know.
Somebody check me that didn't do it the way I did it and see if you come out with the same thing. Now let's take our handy dandy calculator. And since we're multiplying right here, we got to do x to the 3 halves. So that would be math, antiderivative from 0 to 4. 0 to 4 of, what do we, x to the 3 halves? So that would be x to the parentheses 3 divided by 2 and dx. I'm looking for x and enter. And then multiply that by what? 2 pi. And I need somebody to take 128 times pi. I'll do it. 128 times pi. Because y'all sit there looking on the calculator and you won't tell me what the answer is. 128 times pi divided by 5. Divided by 5. Look there, it's a miracle. 80.4247. 80.4247. It's a miracle. Now, why did I do that on the calculator? Because I had no idea what the answer was. So that's why I did it on the calculator to check it. 128 pi over 5. And again, what did I do first? And then I set it up. All right, let's do a nerd. We got time to do a nerd. Let's do one that'll make y'all quit. Where's one that'll make you quit? let's do this one. I don't know if we did this one. I don't think we did, because I think I did it this morning. Find the volume of y is equal to 4x minus x squared. Y is equal to 0. And it is rotated around the y-axis. I'm going to give you 4 minutes. And if you can't get at least to the setup in 4 minutes, that means you suck. And you should probably just go ahead and drop out. And live where? In a van?
Down by the river.
river. And what's sad is some of y'all have no idea what that means. It's your parents' fault. But if I said go live in the Infinity Stones, y'all would know exactly what I'm talking about. Or go live in the dark forest, or where did Harry Potter live? What was that castle called? Smorndorf?
Hogwarts.
See? Y'all know exactly what it's called. It's your parents' fault. Give y'all 3 more minutes. I want to tell y'all something funny. I'm on this, I won the presidential medallion a couple of semesters ago, and I'm on the committee, and you have to pick the next winner. This is no joke. After a year of being virtual, okay, everybody with me? We've been having virtual meetings. We've been having virtual classes. The committee needs to meet. So what do you think the chairman says? Oh, well, we need to meet up here at the Pendleton campus. I'm like, really? Really? You're going to meet to discuss the nominees, and you want everybody to come up to the Pendleton campus? I said, hell to the no, I'm not coming. I said, I'll meet virtually. Can you believe that? It's like, okay, we did all this virtual stuff, so let's just forget about that now and go back to the way we were in the prehistoric days at Tri-County Tech and meet, physically come up to the Pendleton campus and sit for an hour. I just could not believe it. I just really could not. Does anybody have any idea what I'm talking about? I mean, it's like, okay, we need to put all this technical stuff behind us and go back to our prehistoric ways of doing things. The genie is out of the bottle, people. Tri-County Tech has a rude awakening in front of them. They think that they can go back to the way it was. Is that going to be able, is that going to happen after you've got virtual classes started and virtual meetings? You can't put the toothpaste back in the tube. It blows my mind. I cannot believe that somebody would actually say, well, we're going to have a meeting up here at the Pendleton campus. And I'm like, no, we're not. I'm not. Okay, well, some of us want to meet on Teams. We'll have the meeting virtually. Anybody that wants to come to the Pendleton campus can come to the Pendleton campus. Do you think people are going to travel up to the Pendleton campus to have a 1-hour meeting about nominees? I'm sorry. I guess I'm just crazy. Nobody's going to back me up. Y'all don't have any idea what I'm talking about, do you?
No, yeah, Hubert, you tell them, you go.
Does anybody have any idea what I'm talking about?
I think you're
A
talking
little
about
bit.
how they did all the classes that are important online, and then they want to do a meeting that makes you drive 40 minutes for 1
Yeah.
hour.
I mean, does that make sense to y'all? I mean,
No, but I'm still trying to brainstorm how to put toothpaste back into a.
there's going to be some department heads next semester that are going to try to offer nothing but on-campus classes. And you know what? That's not going to work. I mean, who lives outside the Tri-County area? Anybody? Okay, Mr. Benson, where do you live?
I live in Northeast Columbia.
Okay, are you going to walk? I mean, that will upset your whole world, won't it? If you had to come to Tri-County Tech. I mean, honestly. I mean, this is a whole new world. And Tri-County Tech, some of these people at Tri-County Tech, they're going to be like, okay, let's go crawl back in our little shell and let's go do our little campus classes. And it's not going to work. Mr. Sequoia, where are you calling from?
I'm from Greenville.
Okay. I mean, like you said, you would have to actually find another class, wouldn't you?
Yeah. I wouldn't want to
That's
be.
money out of whose pocket? That's money out of Tri-County Tech's pocket. If Mr. Benson and Mr. Sequoia have to go to Greenville Tech to take a class when they could take it from Tri-County and not even leave their house. See? It just blows my mind. Yeah, we're going to have a meeting up here. So what if you're in Anderson or Seneca or wherever, you're just going to come up here. We're going to go back to the way we were doing things before COVID. It just blows my mind. I'll shut up. Some of y'all don't have any clue what I'm talking about. All right, so we got going around the y-axis, and just to save face, it looks like this. And this is 0 and 4. You can set 0 equal to 4x minus x squared, factor out of x. 0 is equal to x, 4 minus x is equal to 0. You get 0 to 4. Y is equal to 0 is the x-axis. So you know that it's going to be in the first quadrant. So this is the area. It's going around the y. So we know that this r is equal to x. We know that from here to here. And that thing's starting from 0 and it's going to 4. So v is equal to 2 pi from 0 to 4 of what? Well, x times 4x minus x squared dx. There's your setup. Now, those of you that didn't have the setup, go ahead and work it. Give you a minute. Because I want you to do as much as you can. Now, curious, Mr. Sequoia and Mr. Benson, why did you take this class? I mean, you could have taken it at Greenville Tech. What made you take this class? Were you a student at Tri-County or what?
I'm a bridge student.
How about you, Mr. Sequoia?
I'm a bridge student too. And I didn't want to live at Tri-County or like live up there, so I wanted to do something from home.
Well, let me ask you this. What are you going to be looking for next semester? Are you going to be looking for on-campus classes or predominantly virtual classes or a little bit of both?
I'd prefer a little bit of both.
I'd probably.
I don't
go
want to
for
be
a little
traveling
bit of both, too.
every day, all day to classes. I'd rather have some time.
What did you say, Mr. Benson? Mr. Sequoia said a little bit of both.
I said I'd probably look for a little bit of both as well.
Anybody else outside the Anderson-Pendleton area?
Yeah, that's what I did too. I'm taking both all virtual and in-person classes just because it would have been easier.
So what are you gonna look for next semester when you sign up for classes?
I already signed up for classes, like for the main ones, like literature and chemistry and genetics. I'm taking those in person, but for minor classes for my minor, I'm just
Take
taking
virtual.
those all on. Yes, sir. I'm just taking all those virtual.
But I think you can agree with me that virtual classes are not going away.
Oh no, not anytime soon, at least.
I don't think they're going away because, like I say, you can't put the genie back in the bottle.
Right.
We've done it. It's out there, and there's some mentality at Tri-County Tech that believes they're going back the way it was before COVID, and I
Yeah,
don't
not
think.
only
Huh?
not only that, but some people will definitely prefer like the online classes as compared to in-person classes, so
Oh
they
yeah.
may take those instead.
Well, anyway, they want to have it on Zoom. I said, well, I'd rather have it on, since we're going to be talking about sensitive information on this committee, I'd rather it be secure with Tri-County Tech, meaning on Teams. They don't even know that Zoom is not internally secure. And these people get me. They just don't know this stuff. Anyway, I'm going to shut up. So V is equal to 2 pi from 0 to 4, 4x squared minus x cubed dx. And that's going to be 4x to the third over 3 minus x to the fourth over 4, evaluated at 0 and 4, multiplied by 2 pi. And the x cancels. So that's going to be 4 times 4 cubed over 3 minus 4 to the fourth over 4 times 2 pi. And I did it. I got 128 pi over 3. But y'all check me. Anybody get the answer? Well, we'll check it. Let's somebody, I'll do it. Because like I said, some of y'all will get the answer and you won't say anything. So I'll just go ahead and do it. 128 pi divided by 3. 134.04. So let's take our handy dandy calculator. And let's go with math. Oops. And go down to antiderivative. And we're going from 0 to 4. And that's going to be 4x squared minus x cubed. 4x squared minus x cubed. Make sure I type it in right. X cubed dx.
Hubert, make sure you get rid of the answer to the -1.
Oh, please. If I hit delete, it's going to delete the whole thing. Delete. 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 Enter. Times 2 pi to second function and 134.04. Yes, that's what we got. Now we just did 2 or 3 good test questions today. So you should feel good. And we still got plenty of time to finish out this section and maybe work on the next section.
Hubert,
All
quick
right.
question about the upcoming exams.
About what?
The upcoming 2 exams.
Yeah.
So are we going over the last test like Monday or so?
The pre-test, I will go over chapter 5 and chapter 6. So I'm gonna break it up into 2 tests. So
Okay,
you're gonna have
so
3 tests to take in the next week or 2.
Okay, yes, sir.
I'm gonna give you to the end of the finals to take it, and you'll have a final
Right.
exam. You're gonna have chapter 5, chapter 6, which will only be like 10 questions on each, and then you'll have the final exam. So y'all got in this class, y'all got chapter 5, chapter 6 homework, and then y'all got 3 tests left. Chapter 5, chapter 6, 10 questions on each, and then the final exam. After you finish those 3 tests, you're done. And we're going to go over those next week, probably the last couple of days of class. All right, I'm going to turn this off. Does that help you out?
Yes, but next week isn't our